So in this video, I'm going to continue the rational inequalities. There's three more of them, and I don't think there's any curveballs here, but let's see what's going on. Let's see what happens, okay? So problem number 4, we're dealing with r squared over r minus 1 is greater than or equal to r. I need to get one side to be 0. So let's see, r squared over r minus 1. I'm going to go ahead and subtract r from both sides. So greater than or equal to 0. You need a common denominator. So r minus 1, r minus 1. All right, so r squared over r minus 1. I'm going to go ahead and distribute with the negative. So it's going to be plus negative r squared and then plus r over r minus 1. Greater than or equal to 0. I'm going to look to combine these two numerators up, look for like terms. One thing I notice is that I have r squared and I have a negative r squared, so those will conveniently cancel. So all I would have left then is r over r minus 1 greater than or equal to 0. So to find the critical values, I'm going to set the numerator equal to 0. I'm going to set the denominator equal to 0. The numerator is straightforward, right? R is equal to 0. Denominator, r equals 1. So my two critical values then are going to be r equals 0 and r equals 1. And I'm going to then put them on a number line. So I have 0 and I have 1. I need some test values, okay? So I need something less than 0. Let's go, I don't know, negative 1 works. I need something between 0 and 1. I'm going to go ahead and test 1/2. You can test 0.5, it's the same thing. You can really test anything between 0 and 1/2. Just make sure it's between 0 and 1. Just make sure it is something between those two values. And something greater than 1, I'm going to go ahead and pick 2. Okay. Using the original inequality, remember that's always your test, go ahead and figure out the left side, figure out the right side, and see what happens when you test it out. When you do this, okay, you will get that negative 1 is true. You will get that 2 is true, 1/2 is not. Okay, it's not a true statement. And the last thing you do is figure out brackets or parentheses. We had an equal to sign the whole way through with the inequality. And so what we're going to do is say that the critical value from the numerator gets the bracket, and the critical value from the denominator will take the parentheses. So negative infinity to 0, union 1 to infinity. Okay, so that's problem number 4. It was actually kind of nice that the quadratic disappeared out of the problem, because then we would have had a rational quadratic. Loads of fun. Let's see, number 5 here. So for number 5, again, I need to get everything to one side. So I'm going to do a little collecting here. So x minus 2 minus 1 over x plus 3 less than or equal to 0. I need a common denominator. My common denominator is the two denominators that I have right now. Let's see, x minus 2, x plus 3. So this first fraction, I have 1. What I was missing was x plus 3. Okay. Minus 1. This fraction was missing x minus 2. Okay. A little cleanup in that numerator. So a little distributive property, minus x plus 2 all over x minus 2, x plus 3 less than or equal to 0. Okay. So cleaning up this numerator still again, looking to combine like terms, x minus x, there's no more x's in the numerator. So I've got 5 over x minus 2, x plus 3. So here's one thing I want you to be aware of. This numerator no longer has a variable in it. It is a constant. You will not get a critical value from a constant, so you just leave it alone. We are still going to get critical values from the denominator. Okay, so set each factor of the denominator equal to 0, and those will get you then your critical values. So let's see, we've got x equals 2 here, x equals negative 3 here. Um, so on my handy-dandy number line, I'm going to have two critical values. I'm going to have -3 and 2. So to test, you could test -4. I would highly recommend testing 0 and 3. Again, you don't have to pick those exact values. I just find, especially with 0, it's easiest to work with. When you do this test, if you test -4, 0, and 3, or really any values, the only thing that should work are any numbers between -3 and 2. All right, so this is the true part, all right, between those two critical values, right in there. And that also, we want to look for parentheses or brackets, but here's the thing. Both of these critical values came from the denominator, so it doesn't matter that this inequality has an equal to component, because both critical values from the denominator, we're going to have to use parentheses on both. All right, that numerator didn't give us any critical values, so we don't even have to worry about it. Let's see, -3 to 2, and that is the interval that is true. So any value from -3 till 2, till +2 will work to make this inequality true, but that's all the values that will work. All right. Last one in our fun little set of rational functions here, rational inequalities. Again, I want to make one side equal to 0. All right. So I need a common denominator. Common denominator in this case isn't too difficult. It's just x, which means got to multiply by an x here. Okay. So let's see. 3x squared minus 5 minus 2x squared all over the common denominator of x. Little combine some like terms. We're going to get x squared minus 5 over x greater than or equal to 0. Okay, here's the thing that's going to be a little bit kind of a mess with this one. This particular numerator doesn't completely factor nicely, but you can solve it for your critical values. So I'm still going to take that numerator, set it equal to 0, and take the denominator, set it equal to 0. Conveniently, that denominator is now done. For the numerator, x squared is equal to 5. I'm going to go ahead and take the square root of both sides. So x is equal to plus or minus 5. So I've got 3 critical values here. I have negative root 5, I have 0, and I have positive root 5. If you are uncertain what the square root of 5 is, use your calculator. It's 2 point something. You don't have to be too terribly specific with it, but knowing that it's 2 point something means that you could use the critical value of, or a test value of -3 here. You could use -1, you can use 1, and then you can test 3. Okay? Using your original, right, always go back to the original. Testing -3 tests false. Testing -1 tests true. Okay, so between negative root 5 and 0 works. Testing +1 is a false test, and testing +3 is a true test. So, parentheses, brackets, what are we going to use? So we did have an equal sign the whole way through. The critical values that came from the numerator will take a bracket. Okay, so we've got negative root 5 and positive root 5 here, but the critical value that came from the denominator, that 0, that has to take a parenthesis set. All right, last thing, write the interval. So negative root 5 to 0, union with positive root 5 to infinity. All right, if you are struggling with any part of this, send me an email message. Let me know how I can help. And as always, if you have any requests for anything, for videos, if you want me to go into more depth on anything, just send me those messages as well. I hope this has helped clarify a few things.